Select the major product of the following reaction. So if we look at our starting material, we see that it contains a benzene ring, which we haven't discussed the chemistry of yet. The other functional group that we see is this ester. So we have an ester, and that's the portion of the molecule that's going to be reacting here. So the key to this one is really recognizing what this reagent is. And if you don't remember and recognize it, it's going to be challenging to come up with the right answer. But so here's the clue. So you see this ALH, that stands for aluminum hydride. So overall, this DiBal-H, this is diisobutyl aluminum hydride. So your hydride reagents, such as this one, these are reducing agents. So this has this general structure. So there's the aluminum hydride. And then here's these isobutyl groups. We've got some steric hindrance and still a hydride that can be transferred. And we also notice that we're doing this at a really low temperature as well. And so what we need to recognize here is that these are conditions for a selective reduction of this ester. So this is going to be a selective reduction. And so if we didn't have a selective reduction, if we were to take this ester and react it with something like LAH, so lithium aluminum hydride and then typically just water, the first thing you would form, your first intermediate would be an aldehyde. This would be the product of adding one equivalent of your hydride reagent, but you would not be able to isolate that. This would just keep on reacting. So you could not isolate that if you're using the LAH. It's gonna keep on reacting because this is powerful enough to react with that ester. It's gonna be powerful enough to react with the aldehyde as well. And so it would just keep on going and give you the alcohol, right? So that primary alcohol. So if you want to get the aldehyde, you need different conditions, right? And so this DiBal-H at -78, it's gonna add a hydride, and it's gonna give you an intermediate, a tetrahedral intermediate. It's just gonna stay there at low temperatures until you add water. And so ultimately the product is gonna be the aldehyde. So this is a way to take an ester and selectively reduce it to the aldehyde. So something that cannot be done with that more powerful LAH. That means that our answer here is D.